This is now section 15.7 on triple integrals in cylindrical coordinates. So on page 1040. So you might recall we did cylindrical coordinates before, now we're integrating. So key formulas, put these on your cheat sheet if you wish. X is r cosine theta, y is r sine theta, and you leave z alone. R squared equals x squared plus y squared, and tangent of theta is y over x. And so that was polar. And we have this picture, as you know. So x, y, z becomes r theta z. It's polar coordinates and just leave z alone. So when you integrate, as you might expect, page 1042, and here's the basic formula that you need. So if you have integral of f of x, y, z, dv, if it's convenient to change to cylindrical coordinates, which is polar coordinates, except leaving z alone, usually, I mean, sometimes you could leave y alone, you could leave x alone. Okay. So notice a form of dv. dv is r dz dr d theta. In polar coordinates, you might remember that dA was r dr d theta. So in cylindrical coordinates, just leave z alone. So what does all this mean? Anytime you see x, change it to r cosine theta. Anytime you see y, change it to r sine theta, leave z alone. That's provided z is the variable that you are leaving alone, which is going to be true most of the time. And then again, multiply by an extra r, and then dz dr d theta in some order. Okay. So that's doing triple integrals in cylindrical coordinates. Okay, so that. A little bit of work in cylindrical coordinates. And it's just polar coordinates and leave z alone. Comes here. Okay. So number one, I superscript with a C for cylindrical 4 pi over 3 negative 2. So by formula, x is r cosine theta, y is r sine theta, leave z alone. So 4 cosine pi over 3, 4 times a half, 2. R sine theta, 4 sine pi over 3, 4 times radical 3 over 2, 2 radical 3. And you leave z alone. So the point 4 pi over 3 negative 2 in cylindrical coordinates is 2 radical 3 negative 2 in rectangular coordinates. Okay, so you go to 60 degrees. Remember, here's x. You walk out 4 units, and then you drop 2 units. What is that in traditional x, y, and z, rectangular? Negative 2, 2 radical 3, 3. Oh, I'm sorry, 2 radical 3, negative 2. 3b, in rectangular coordinates, negative 2, 2 radical 3, 3. Okay, so what is it in r, theta, and z? Well, you know z is going to be 3. That stays the same. So r is the square root of x squared plus y squared. So negative 2 squared is 4. This thing squared is 12. So r is 4. Theta, I drew myself a little picture. Negative 2, 2 radical 3 means 2 units that way, 2 radical 3 that way. And that makes the hypotenuse 4. Side opposite the 30-degree angle is half the hypotenuse. So this is 30 degrees, which makes this 60 degrees, which makes this 120 degrees, or 2 pi over 3. So cylindrical coordinates of negative 2, 2 radical 3, 3 is 4, 2 pi over 3, 3. Okay, number 5, r equals 2. That's x squared plus y squared equals 4. Okay, that's the shape of a cylinder, because x squared plus y squared equals 4 is a circle, and then z has no limit, so z is unbounded. It just goes up and down as much as you want. Okay. Think of your normal x squared plus y squared equals 4, circle, center of the origin, radius of 2, and then z can be 1, 2, 3, 4, negative 1, negative 2, anything that you feel like after that. Okay, 7, r squared plus z squared equals 4. Well, r squared is the same as x squared plus y squared plus z squared equals 4. So that's a sphere, center of the origin, radius of 2. Okay, 9a. So I see x squared plus y squared is r squared, and I change r to x to r cosine theta. So r squared minus r cosine theta plus z squared equals 1. Okay, so now for some integrals. 17, integrate. So triple integral over the region E of radical x squared plus y squared dv. So we know x squared plus y squared is r squared, whose square root is r. Okay. Z is going from -5 to 4, and the other bound is x squared plus y squared equals 16. Well, that's a circle center of the origin with radius of 4. So this thing is r, and then you multiply by an extra r because, again, dv is r dz dr d theta. Okay, so z goes from -4 to 5, r goes from 0 to 4, theta goes from 0 to 2 pi. Okay, that's going to be r squared. That does not affect z, so the length of the interval for z is 9, 5 minus a -4. And this thing's not going to depend on theta, so the length of the theta interval is 2 pi. So 9 comes out, 2 pi comes out, and all you're integrating is r squared, dr. So that's r cubed over 3 from 0 to 4. Plug in 0, you get 0. 18 divided by 3 is 6. So 6 pi times 4 cubed, which is 64. Final answer is 384 pi. Okay, 19, triple integral of x plus y plus z dv. So you're underneath z equals 4 minus x squared minus y squared. That's 4 minus parentheses x squared plus y squared, or 4 minus r squared. And it says you're in the first octant. Okay, so x becomes r cosine theta, y becomes r sine theta, plus z, r dz dr d theta. Z goes from 0 to 4 minus r squared, r goes from 0 to 2, theta goes from 0 to 2 pi. All right, so I distribute the r. So let's see what happened here. Oh, I'm sorry, I'm integrating with respect to z. Right, so r cosine theta plus r sine theta z, this is all considered constant as far as z is concerned, plus z squared over 2. Z. Z goes from 0 to 4 minus r squared. Okay, so now everywhere I see a z, I got to plug in a 4 minus r squared, which is here and here, so it gets a little bit sloppy. Okay, so distribute all this stuff. 4r cosine theta minus r cubed cosine theta, I'm foiling essentially. 4r sine theta minus r cubed sine theta plus 1/2 of that thing squared, which comes out to be 1/2 r to the 4th minus 4r squared plus 8. So 4r cosine theta minus r cubed cosine theta plus 4r sine theta minus r cubed sine theta. You can see this gets really long. 1/2 r to the 4th minus 4r squared plus 8 dr d theta. So integrate with respect to r. 2r squared cosine theta minus r to the 4th over 4 cosine theta plus 2r squared sine theta minus r to the 4th over 4 sine theta plus 1/2 r to the 5th over 5 minus 4/3 r cubed plus 8r from 0 to 2. Plug in 0, you get 0. Plug in 2. 8 cosine theta minus 4 cosine theta plus 8 sine theta minus 4 sine theta plus, let's see, 32 over 10, which is 16 over 5, minus 32 over 3 plus 16. Okay, then a little bit of combination here. All of this comes out to be 128 over 15. So that comes out to be 4 cosine theta, 4 sine theta, 128 over 15. All right, so integral of 4 cosine theta is 4 sine theta. Integral of 4 sine theta is -4 cosine theta, and that's 128/15 theta. Okay, plug in pi over 2, I get 4 plus pi over 2 cosine pi over 2 is 0. And 120 over 15 times pi over 2. Minus plug in 0, that's 0. That's a minus 4, and that's a 0. Okay, so I end up with 8 plus 64 pi over 15. Get done properly. Okay. 23 is a little bit clumsy. Z equals radical x squared plus y squared. That's R. Okay. If I square both sides, I have z squared equals x squared plus y squared. And the sphere x squared plus y squared plus z squared equals 2. So again, I have this ice cream cone thing looking under the sphere above the cone. Okay, so that's where I'm integrating. Okay, if I solve this, I have z equals radical 2 minus x squared plus y squared, which is radical 2 minus r squared. Okay, the boundary turns out to be the unit circle, trying to find out where this touches this. So z squared equals x squared plus y squared, and z squared equals 2 minus r squared. Okay, well, that basically means z squared plus z squared equals 2. Z squared equals, which means 2z squared equals 2, z squared is 1, or z equals 1. Okay, so the height is 1 right here where they touch. Okay, and coming straight down, that would be the unit circle in the xy plane that I'm integrating over. So for the volume, I'm integrating upper minus lower. So the upper is radical 2 minus r squared minus r. And then r dr d theta. All right, so distribute to r. R goes here, r goes here. So by the way, I took out the 2 pi, since this is it doesn't depend on theta. So split into 2, I have r radical 2 minus r squared. If I do a u substitution, u equals 2 minus r squared. Du is negative 2r dr, so I need a negative 2 inside and negative half outside. That's going to be easy. So that's 2 minus r squared to the half. That's going to be a negative 1/2. 2 minus r squared to the 3/2 times 2/3 from 0 to 1. That's r cubed over 3. Let's get this out of the way. Plug in 0, you get 0. Plug in 1, you get 1/3. This one's a little bit tricky. If you plug in, let's see, if I plug in 1, I have 2 minus 1 or 1. Minus plug in 0, I have 2 to the 3/2. So 2/3, factor out the negative 1/3. 1 minus 2 to the 3/2, 2 radical 2 plus 1, or negative 2 pi over 3, 2 minus 2 radical 2. Okay, or a little bit of touch up, 4/3 pi radical 2 minus 1. Okay, 29. You can make it a lot easier by switching to cylindrical coordinates. So let's see, that's the same as r. R2, x is r cosine theta, leave z alone. dz dx dy becomes dz r dr d theta. R goes from 0 to 2. Negative radical 4 minus y squared to positive radical 4 minus y squared. R is going to go from 0 to 2, and theta goes from 0 to 2 pi. This is a circle, center of the origin, and radius of 2. Okay, so that's going to be r times r squared, cosine theta. Integral of z is z squared over 2, and you're going from r to 2. So plug in 2, I get 4 divided by 2, which is 2. I leave this stuff alone. Plug in r, you have r squared over 2. Then it's dr d theta. Okay, and then I notice if I distribute here a little bit, I have stuff with r, integral of cosine theta. That automatically means if I switch it to cosine theta d theta dr, it's automatically going to be 0. Right? It doesn't matter what this comes out to be. It's going to be some constant. And then you're integrating from 0 to 2 pi of cosine theta. So that's automatically going to be 0. Right? Go for the cosine function, looks something like this. So as much area above as below the function from 0 to 2 pi. So the answer is automatically 0. All right, so that's section 15.7.